Warm greetings to everyone. So today we are going to discuss about a topic real numbers from the class 10 NCERT. So before going to start this topic real numbers, okay, so let me recall a few concepts from class 9. So here in the class 9 we have already learned about how to represent rational numbers on the number line. We have already learned about how to represent irrational numbers on the number line, and we know what is the difference between rational and irrational number, right? So coming to the rational number, when you notice the difference between rational and irrational. Now when a number is written in the form of p by q, when a number is written in the form of p by q, where q is not equals to 0 and p comma q, what p comma q, okay, are integers and HCF of p comma q should be 1, right? So if a number is in the form of p by q, q is not equal to 0 and p comma q are integers and their HCF is 1, then we call that numbers are a rational numbers, right? Now coming to the irrational numbers. So what is meant by irrational numbers? Irrational numbers are nothing but what? A number which we cannot represent on the number line. Yes or no? So a number which we cannot represent on the number line. So such type of numbers are called what? Irrational numbers. Such type of numbers are called irrational numbers. For example, if I have a number root 2. Okay, if I have a number root 2, so can we represent the exact value of root 2 on the number line? We cannot represent. Why? Because here root 2 is a value which is non-terminating, non-recurring decimal, right? When you write a solution for root 2, so which is a non-terminating, non-recurring decimal, so that is the reason we cannot represent root 2. What? We cannot represent root 2 on the number line. We cannot represent root 2 on the number line. For example, if I have a value 1 by 2, can we represent 1 by 2 on the number line? Yes, we can represent 1 by 2 on the number line. Yes or no? So as it is a proper fraction, so the number will be lies in between where and where? Obviously 0 and 1, right? So 0 and 1 in the sense, obviously 1 by 2 is nothing but 0.5. So we can easily represent 1 by 2 on the number line, right? So if I have a number 1 by 3, if I have a number 1 by 3 is also approximately what represent on the number line. Why? Because it is a non-terminating, right? When we solve the value for 1 by 3, the value will be approximately what? 0.33333 and so on, right? What does that mean? 0.3 bar. So which is a non-terminating recurring decimal, right? Non-terminating recurring decimals are considered as a rational numbers. So what are the irrational numbers then? The irrational numbers are only the numbers that are non-terminating and non-recurring. So that non-terminating, non-recurring. For example, 1.2469356 and so on. So here, whenever you observe any value on this particular number, so the value is non-terminating. It means what? Which don't have any end value, as well as a number is not repeating here. Yes or no? So these kind of numbers are called what? These kind of numbers are irrational numbers. So irrational numbers exactly we cannot represent on the number line. Right? So here you know how to represent 0.3 bar on the number line. Already we have learned in class 9. Okay, class 8 we have already learned. Now, so let's move to the next topic, sir. The next one is, okay, what are the topics we are going to learn in this real numbers? So we learn about introduction, that is nothing but which is a small introduction from class 9 to class 10, and after that Euclid division lemma, which is a very important topic in a class 10, and the fundamental theorem of arithmetic. So these two are the very important topics in the class 10. After that, revising the irrational numbers and revising the rational numbers and the decimal expansion. Now coming to the next concept, introduction. So introduction in the sense what? Now so we know that what are the type of numbers. So generally the numbers are what? Natural numbers we know. Okay, the natural numbers are represented with n. So that is nothing but what? All counting numbers. The numbers which we use it to count, such numbers are called what? Such numbers are called natural numbers. Like what? 1, 2, 3 and so on, right? Whatever the numbers we use it to count, such numbers are called what? Natural numbers. Now, if I go with whole numbers, what are the whole numbers? The whole numbers are nothing but what? When 0 is included with natural numbers. 0 is also included with natural numbers. So, all such numbers are called what? Whole numbers. Now, coming to integers. Integers in the sense which is a combination of positive natural numbers as well as negative natural numbers along with the value 0. right? So positive natural numbers and negative natural numbers as well as 0 are called integers. That is nothing but what? Like what? -3, -2, -1, 0, 1, 2, 3 and so on, right? So here when you observe, these are the negative natural numbers, these are the positive natural numbers, and when 0 is also included along with the negative and positive, so we call such numbers are integers. We call such numbers are integers. Now coming to the rational numbers. Rational numbers are represented with Q. Okay, rational numbers are represented with Q. So rational numbers are which is in the form of P by Q, where P comma Q are integers and HCF of P comma Q is 1, right? For example, if I have a value 2 by 5, can I consider that 2 by 5 as a rational number or not? Now, before going to find out the whether the number is rational or irrational, first you have to learn what is the HCF. HCF is nothing but what? So HCF of two numbers is nothing but what, sir? And now two numbers are having two numbers are having a highest common factor. Whatever the number we are taking, so that number is the highest common factor of the given two numbers. Like if I take 2 and 4, what are the factors of 2 and 4? Now, if you write for 2, what are the factors of 2? 1, 2 are the factors of 2. If I write for 4, what are the factors of 4? 1, 2, 4. 1, 2, 4 are the factors of 4. Now, when you observe here, 2 is the only number which is the highest common factor. 2 is the only number which is the highest common factor of the number 2 and 4. So, what does it mean? Here, 2 is HCF of 2, 4. That's it. Now, when you observe 2, 5, whether the number 2, 5 is rational number or not. So now, when you are finding out whether the given number is rational or not, you have to learn, you have to find out whether the given number's HCF is 1 or not. Now, when you observe, when you write the factors of 2, 1, 2, when you write the factors of 5, 1, 5. What is the highest common factor? The highest common factor is what? 1. So 1 is the highest common factor. So that is the reason. So HCF of 2, 1, HCF of 2, 5 is 1. HCF of 2, 5 is 1. So that we can consider this as a rational number. Now, if I have a number, 4 by 8, can I consider this rational? Can I consider this 4 by 8 as a rational number? No. Why? Why? Because when you take HCF of 4, when you write the factors of 4 and 8, what are the factors of 4? Coming to the factors of 4, 1, 2, 4. Coming to the factors of 8, 1, 2, 4, 8. Right? What is the highest common factor? The highest common factor. The common factors are 1, 2, 4 are the common factors. Among the three factors, the highest factor is 4. Yes or no? The highest factor is 4. So that is the reason, as HCF is 4, we cannot call 4 by 8 as a rational number. We can call it as a fraction. So if you simplify it in the form of when you divide with the 4, 4 1s are 4, 4 2s are 8, so 1 by 2. So we can call 1 by 2 as a rational number now. Right? So whenever we write the given fraction in the simplest form, then if the HCF is 1, 1 of the number numerator and denominator, then we can call it as a rational number. Otherwise, it is not a rational number, right? So rational numbers are nothing but what's a rational numbers? The numbers which we can represent on the number line. The numbers which we can represent on the number line, such numbers are called rational numbers. Now, coming to the next one, irrational numbers. Just now we have discussed about the irrational numbers, right? So now, irrational numbers are nothing but what, sir? When a number is not represented, it is not possible to represent on the number line. Such numbers are called what? Irrational numbers. Such numbers are called irrational numbers, right? What just now we have discussed. I have a number 1.245679384 and so on. Can I represent this number on the number line? We cannot represent this number on the number line. Yes or no? We cannot represent this number on the number line. Yes, am I right? So that is the reason this is an irrational number. So all the irrational numbers in the form of what? Root n, where n is a prime number. N is not a perfect square. Take n is not a perfect square. Yeah, we'll move to the next slide now. So let me give a simple example regarding the Euclid division algorithm. After that, we will go with the what actual problem and actual definition. So actually, this is a puzzle which we have which we have in a textbook, in our NCERT textbook. Now, when you write a trader counting X of a basket, if counting in pairs, one will be remain. Okay, one will be remains. If count in threes, 2 will be remain. If count in fours, 3 will be remains. If count in fives, 4 will be remain. If count in 6, 5 will be remain. If count in 7s, nothing will remains. And my basket cannot accommodate more than 50. My basket cannot accommodate more than 50. It means what? If we count in pairs, pair in the sense what, sir? If we count in twos, one will be remain. It is nothing but what? So now I am taking 2a plus 1. Yes or no? If count in pairs in the sense what, sir? That should be the multiple of 2. Okay, so that is the reason I have written as 2a and 1 is remaining, that is nothing but 1. Okay, if we count in 3s, what does it mean? It is nothing but what? Okay, so multiple of 3, I am taking 3b plus 2. 2 will be remain, yes or no? 2 is remain. After that, if count in 4s, what happens? 4c plus 3. If count in 5s, what happens? 5d plus 4. If count in 6, 6e plus 5. If count in 7s, nothing will remains. Nothing will remains in the sense what? 7f plus 0. When nothing is remainder. So what we have to consider? For example, if I have a number 4, if I divide with 2, what happens at 2 2s are 4 by subtracting 0. Yes or no? What does it mean? It means that 4 is a multiple of 2. If the remainder is 0, then we can call the dividend is the multiple of divisor. Yes or no? That we have already learned in our previous classes, like class 4, class 5, class 6, or in all these classes we have learned about this, right? In the same way, when you multiply with 7, when you count in 7s, nothing will remain in the sense what, sir? What does it mean? It means that remainder is 0. When remainder is 0, what does it mean? It is the multiple of 7. Multiple of 7. Now, we will solve this. Okay, we will solve this question here. Now, when you observe, okay, now here you need to observe one thing, sir. Whatever the value we got in the remainder, whatever the values we got in the up to 6, okay, up to 6. So here, remainder is 1, the divisor is 2, remainder is 2, the divisor is 3, remainder is 4, the divisor is, okay, remainder is 3, the divisor is 4, remainder is 4, the divisor is 5, remainder is 5, okay, the divisor is 6. So when you observe, okay, remainder is nothing but what? 1 less than divisor. So d minus 1, 1 less than divisor. Yes or no? Remainder is 1 less than divisor. Now, whatever the number we take here, whatever the now, okay, count of x, whatever the number of x we have take, so that should be the multiple of 7, as well as that whenever you divide, that should be, okay, that should be less than 1 of the divisor, right? So now, let the number of x be x. Let the number of x be x. Now, come on, start counting. So here, whenever a number is dividing with these numbers and what? 1 is less than, right? So it means what? The LCM, whatever the, okay, you need to find the LCM of 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Now when you take LCM of 2, 3, 4, 5, 6, here my LCM is 60. LCM is 60. Now 1 less than, so 60 minus 1 is equals to 59. Is this 59 is multiple of 7? Is this 59 is multiple of 7? Obviously no. Yes or no? Now write down the next multiple. The next multiple is 120. 120 minus 1 is equals to how much? 120 minus 1 is equals to 119. So 119 is multiple of 7. So it may be possible. Now we will see for the another number. So here the next number is 180. Okay, 180 minus 1 is equals to 179. 179. So 179, but okay, if I subtract 1, what happens, sir? 179 I got. So here the number of x, what they have given? They have given that we should not, okay, the box cannot accommodate for more than 150. Here we got 179. Is it possible? Obviously no. So what will be our answer? Our answer may be 119. 119x. Clear? This is about the example, puzzle they have given in the NCERT textbook.